Xin chào tất cả mọi người. Merry Christmas everyone and welcome back to HCLTech Vietnam TikTok series. And I would like to send my greeting and thank for your present in today, the virtual session, product design and how it can be accelerated using computer aided engineering. And another Saturday here, but it's a very special morning, right? And Christmas is coming to town and I appreciate that you are here. My name is Mai, marketing senior, and I'm your host. But now we are waiting for more people to join.
Progress. It comes from having a clear objective, a goal, moving forward unwaveringly towards success. It can be fast, it can be slow, it can be disruptive, but one thing it can't be is stopped. While progress might seem inevitable, breakthroughs come from supercharging it, delivering business outcomes at scale, fulfilling aspirations with compassion, innovating responsibly, finding new levels of efficiency, removing barriers, unlocking potential. Business is always moving, so it's easy to confuse motion with real progress. Whether it's day-to-day success or transformational gains, we supercharge progress to change the game. HCLTech, supercharging progress.
Yeah, so welcome back. I know a lot of you here have attended our webinar before, and surely you already know about us. But for people who are newcomer, I'm gonna show you more about HCLTech Vietnam. You can see HCL Vietnam started over a years ago, and as on date, we are located in two locations, Hanoi and Ho Chi Minh City. We are serving 30 plus global customers from both locations with a diversity ratio of 27%. HCL Vietnam has also successfully set up a university partnership program where we have got over 15 universities. Our focus area for Vietnam is high-tech area, which also includes digital transformations as a key focus area for us. The domain where HCLTech Vietnam is focusing on from banking, insurance, other financial services, automobiles, or manufacturing, pharmaceutical, medical device, CPG, and retail. We recruit people who are experienced professional in Vietnam. We also look at fresh university graduates and also students who are all undergoing their university education in the 7th and 8th semester. And yes, in the next 3 years, HCLTech Vietnam is poised to grow to strength of 3,000 employees to provide services to clients in various high-tech and cutting-edge technologies. If you have interested in career opportunity at HCLTech Vietnam, please visit our website, hclvietnam.com, and follow our fan page to find out available jobs. And yeah, attend our virtual session today. We have Mr. Dr. Ganga Reddy C, Operation Director EIS HCLTech, to share the update on computer-aided engineering. Ganga Reddy is an experienced organization leader with strong technical, business, and leadership experience in product development, light attention, and aftermarket programs across aerospace. He currently heading Mechanical Center of Excellence under Engineering R&D Services, which comprise of CAE, Product Reliability, Industrial Design, Manufacturing and Engineering Services, Product Cost Management, and Product Testing COEs. Now he is focused on developing innovative solutions, thermal simulation of cryogenic cooling for high-performing devices like cloud service, and which facilitates multiple participants across geo to virtually join and work together without being present in person. Creation of top flow for usability engineering process for new product development to address evolving market needs, which are using across various industries. And you may send in your question at any time during the presentation. We will collect these and address them during the Q&A session at the end of today's presentations. For those of you just joining us, welcome. Now, without further ado, I will turn the time to our speaker, Mr. Ganga. Hello.
Good morning.
Yeah.
You are able to hear me, right?
Yeah, I see you. So please head up to know more about computer-aided engineering right now, please.
Thanks, Mai, for that. You are kind enough to introduce me. So good morning, everyone. As Mai said, on the eve of Christmas, I'm very glad to be in front of you. In next 40 to 45 minutes, I'll take you through what are the avenues in computer-aided engineering. How is CAE going forward? I'll call computer-aided engineering as CAE is accelerating the product design in all facets, right? So I would like to see more questions from you going forward. Please send it to my. She will read out to me. I'll try to answer as much as possible. So quick agenda for today's session is I'll start with the introduction, and then when I say introduction, and then probably some of you might be looking for a career in the CAE area. While choosing, you will also be interested what will be the career prospects going forward, which will partially be answered through CAE global market trends, how this particular service line is growing worldwide. And also we'll give you, if at all, if you join HCL, what will be the CAE team looks like, how big it is, and what all are the areas you can look for to work. And then what all are the current customer business challenges, which is an opportunity for all of us to solve their business challenges that I'll touch upon. And I'll also briefly touch upon CAE solutions throughout the product life cycles and some of the HCL CAE driven solutions. And you will also get to see what is the CAE services of HCL to achieve the product excellence. Now, why choose HCL CAE? That will be most important in case if you decide to join in the post your university education. And once you join, what will you see in HCL in terms of process, tools, methodology, and standardization? And then as soon as you come from universities and join us, how do we train you guys, or else any freshers who come in from the universities will also touch upon the CAE Academy framework so that we dedicatedly train the people and make them ready for the industry, solving industry problems. And last one, question and answers. Mike, you can move to the next slide. Okay. Brief introduction to CAE. Before getting into the CAE, I'll touch upon the product development process on the right hand side. First image, what you are seeing, the circle. Any product development process, it starts from the customer need, right? After the once understanding the market research and customer need, the core group gets into the brainstorm to address the need of the customer and also including the user experience. Once after the brainstorming, they go to the define the product uh, uh, landscape. Once the definition phase is over, then we get into the design phase. Once the design is done, that has to be validated through the testing. And then after the testing, it successfully meets all the criteria, the service loads, and then the end user intent, then we'll launch the product. That is how the product life cycle. But in that product life cycle, what is computer-aided engineering role, and how does it plays effective role in terms of shortening the overall product development life cycle? That is what we'll focus, right? On the right topmost corner, you can see CAE role in design development and validation. Once the definition phase is over, the CAD model will be developed. That is the conceptual model will be brought into a CAD model, that is a 3D model. Once the CAD design is done, then the product development process, digital markup will be done. Once the digital markup is done, you will have to do the validation of this product throughout, whether it is at a conceptual stage or at a detailed design stage or else preliminary stage. Now, this is where the computer aided engineering is used, right, which is a almost alternate to virtual testing, which uses sophisticated analytical algorithm for a design validation of the design. So when you design a product and then you build a prototype, you do the testing, you can only see certain parameters whether it endures the service loads throughout the life cycle, or else whether it will fail. But what happens internally, let us say automotive, the fuel is flowing, what will happen inside the ducts, or else what will happen to your transmission systems, all that thing you can virtually visualize using the CAE. That is where the CAE becomes very important. CAE allows to perform virtual validation of this product about the physical properties, may it be strength, or else the life, or else the flow characteristics. All that parameters can be visualized and also can be reported out. So without needing a physical prototype. In nutshell, whenever you are doing a product development, after design, you will have to build a prototype, you have to test it, and then you'll realize that okay, this design is not working out. You have to again go back to the design room and then improvise the design. So the overall product life cycle time was more, and also the cost involved was very high because of building the prototype, testing it, then you realize that it is not working. The process is very iterative one. So all that iterative one can be eliminated through the virtual validation, that is called as your computer aided engineering, CAE. The most commonly used simulation analysis types are the finite element analysis, which is predominantly used for validating the strength or durability of the product, or else the dynamic behavior of the product. How does a product behaves under the vibration? Or you, let us say, some of the products which will have a lot of computational flow, or else fluid flows. For an example, automotive, a car when it drives on a road, what is the aerodynamic characteristics, how do you evaluate that? That will be through your computational flow dynamics. Or else an aircraft when it takes off against the wind loads, how does it behaves? Again, the aerodynamic analysis comes into picture. Many of the components can be subjected to severe environmental condition, high temperatures. So at that time the thermal analysis has to be done, and many of these designs will not be undergoing only one kind of service loads, which is the fluid loads, or else the structural loads or vibration loads. That is where the multidisciplinary simulation also becomes important. The other important is multi-body dynamics, and the finally the optimization. How do you do that? At the bottom you can see some of the important some of the use cases what we have done. So on the left hand one, the first one, the backhoe loaders of a heavy construction equipment, when it loads, how does it behaves? And the second one is a bottle, simple bottle, a shampoo bottle, or else uh, sanitizer bottle. When you squeeze it, how does it behaves? That can be visualized using the CAE. Now, with that brief introduction, now let us question ourselves: does any of our design operate in only one domain? Certainly not, right? So there might be a relative motion between two components that becomes your kinematics, a component which is moving, which is under motion, or else it might be subjected to a lot of vibrations when it is on the road, or else when it is operating. For an example, consumer product like washing machine. So a lot of vibration, that is your dynamics. So it may also generate noise. So acoustic study becomes important. Then it is subjected to repeated loading at a periodic interval. Then its life, that is the fatigue life, you need to evaluate. Structurally, whether it is durable, or else or else how much noise it is generating, the thermal whenever it is subjected to severe temperatures. So any design, given design, will never operate in a single domain. There will be multiple aspects which we'll have to design. Whereas when you build a prototype and test it, you will be able to test it for one or two of these domains. But in CAE, multiple of these domains can be simulated at the same time and then visualize how is your product is going to behave, right? So how do you develop the insight? So into all these domains is the multidisciplinary optimization or as the co-simulation. Right? Can you go to the next slide? Okay. So why co-simulation or multidisciplinary optimization is required? You can see here on the right top corner the image, the simple wing I have taken of an aircraft. So it will be subjected to the wind loads and also the structurally. So it may have a flutter or else it may have a vibration. So the vibration induced by the wind, there is a flow as well as the structure. There is an interaction of flow and structure that has to be combinedly simulated. Otherwise what happens, structurally you do analyze what is its effect, you will come to know, and later you will simulate or else you can analyze for the only fluid flow, what is the loads coming onto the uh, wing because of the wind. Then you will have to superpose those results and then see what is the combined effect. Now there is no need, with the advent of a lot of computing, now you can co-simulate both structure as well as the fluid at a time. In the bottom corner what you are seeing is the one of the simulation which we have done for a you know uh, naval aircraft where it lands on the navy deck, right? So after landing, the aircraft landing onto the naval deck, within 90 meters the aircraft has to be brought into a rest. Otherwise what happens, it will plunge into the sea or else it will have to take a ski jump. Both are dangerous. So in that case, how do we simulate that? That can be done. Here the fluid flow will be there, aircraft will be moving, and then the structural simulation also is very important. On the right bottom corner what you are seeing is a simple exhaust of a two-wheeler, wherein you will have to see what is the noise it is generating, the one, and also the temperature, because it will be operating at a severe condition. So at what temperature or else what it is throwing to the environment, exhaust. On the other side, the acoustics. All these different domains can be virtually validated. So what does it gives? It gives us a holistic performance rather than a single domain. How does it performs? You superpose everything at a time and then see that you can visualize also. It is deflecting more than the allowed, or else it has a more stress so that than the allowable, it may fail. During the conceptual stage, or else during the product development phase itself, you can fine tune your design so that when it goes to the certification, there will be no surprises. In the melee, there is an increased accuracy and then the precision, so that there are very minimal failures. That is where you can see that in any of the products now, whatever the design life is assured, they meet by and large 99%. That is the reliability. And then the faster analysis, overall product life cycle time can be reduced here, which is very unique as well, which you will not be able to see in the physical testing or else the product development. Now, the other important use case which I wanted to put, when we are developing a automotive or else a car, right? What all parameters it is very important to you, whether your car is durable or else how does the vehicle dynamics, the vibration, is it getting transferred to the passenger? That is overall vehicle dynamics, or else because of this vibration, any part is getting damaged. And the third most one is the comfort. Now, apart from simulating this at a time, there is a virtual test drive also you can do it. There are tools available. So both the overall product development, right from the durability, the vehicle dynamics, acoustics, the comfort, and virtual test drive, all these put together can be simulated and then upfront decision can be taken so that there will be no issues at the later stage. And at bottom you can see there is a diaphragm valve. There is a jet of fluid which will be impinging, that may have a non-linear deformation on the diaphragm here. So what is it? Non-linear behavior of the material you are simulating, and also the fluid flow phenomenon you are simulating. Two domains you are simulating at the same time. Similarly, a water jet which will be impinging onto a plate, what will happen? This plate, whatever you are seeing green, it will deflect enormously based on the fluid pressure. That means that at what pressure this plate will not go beyond the linearity that we can assess and then give the inputs to the designer upfront. Whereas the other one, any rotating, you take an example of fan, right? So what all important here? Both the fluid flow as well as the structural behavior. You can club both together and then take a design decision during the product development. Okay. So with that brief introduction, I'll go. Okay. This is some of the important aspects or else interesting factors what you learned about CAE in a small time. Now, let us say if you decide to pursue your career in CAE after your graduation or post graduation from the university, what is in it for you? Why should you pick this CAE as career? One is it is very niche compared to the any other mechanical engineering aspects. All functions are very important, right? I don't say one function is more important than other, but this is much more niche. The availability of the skill set people are minimal compared to the manufacturing or some other aspects of the product development. So now, what does the CAE global market trend says? Many of the analysts, it is a published data, right? We have also given you from which sources we have taken. As of now, in 2021, the overall CAE market, the aggregated value was at 8.79 billion US dollars, which is expected to go up to 16.2 billion in 2022. That is in 6 years time frame, almost the revenue cap or as the market size will double up. That means that the number of resources required or engineers required will also double up in next 6 years. That is where the CAGR cumulated growth rate is 9.2% year on year. That means close to two-digit growth. It is always says that it is one of the most prominent area wherein you can pick up this career so that you will have a long-lasting career and rewarding career as well, which is challenging, and you will also be getting to work on niche skill on various domains. This CAE can be applied to the various domains. Mai was showing in earlier what are the industry verticals we work, right from aerospace to automotive, medical equipments, industrial manufacturing, consumer product groups, telecom, or semiconductor. In all these areas, since this is a physics-based design algorithms, so irrespective of the domain, we can deploy these techniques. So in the nutshell, what I want to communicate is we have an impressive growth predicted for CAE industry in next 6 years, with more focus on simulation-based product design. That means that the product design earlier in Aero, it used to be one new product development cycle used to be somewhere close to 8 years. Now it is shrinking it to 4 to 5 years. Reason being, lot of testing is evaluated. The certification is done by pass-through comparison. What is that? Design improvement, right? So the important phase of building the lot of prototypes, it is eliminated, and then the testing is minimized. So these two areas of building the prototype and testing were taking longer time, which I'll touch upon in the subsequent slides. That can be eliminated as much as possible. That's where the overall product life cycle time is shrinking, and similarly in the other domains. Okay. Just you can to focus on what are these top technologies which is driving CAE as a whole service line is. you can see the with a lot of artificial intelligence and machine learning that is embedded into CAE techniques now. And then we are at a very exciting phase of technology where the conventional IC engines is getting transformed into, you know, battery based fuel system. So there is a question mark about the conventional IC engines, what will happen in the automotive industry. Similarly, in aero also, there is a eVTOLs we are talking about for the urban mobility, wherein the electric vertical takeoff aircrafts with 3 to 4 members ferrying within the cities, which is happening. Slowly, it will also get into a commercial aircrafts as well. May not be complete electric, but hybrid mode. That means that, and also most of the vehicles or machines are connected because of the IoT and the advancement in the telecom as well. So these components, lot of electronic components will come into our machines because of the controls, all those things we are putting in. The electronic thermal management becomes very important. And then the automation. Now that each and every segment is getting automated, even the CAE is no different. You can automate lot many processes so that you can speed up whole process. So these are some of the, on the left hand side, I'm showing you, right? Artificial intelligence and machine learning driven designs, the electronic thermal management, or else CAE automations, or battery management system. How do you evaluate how fast the battery can be charged? Those are some of the technologies which is driving the CAE as such, right? Out of CAE, there are multiple aspects of it. As I said, finite element analysis, which is predominantly used for evaluating the strength, the durability, or life of the product or vibrations. That constitutes to 44%, right? The 30% is computational fluid dynamics, whether it is aerodynamics or flow through any ducts, or else this electronic thermal management. And then there are optimization and multi-body dynamics. So 17% and 9%. Predominantly finite element analysis or computational fluid dynamics, it constitutes to 75%. You can see how consistently the CAE service line is growing year on year. I've captured at least for 10 to 12 years. Nowhere in a single year this growth has come down. The requirement or else need for CAE is continuously growing. That is at 9.2%. Okay, with that introduction about how the market looks like, I'll move forward. Suppose some of you were here in this call. If you decide to join HCL team as a CAE group, which is a center of excellence, what do you get? What do we do within HCL? So, in terms of, as I already said, structural analysis, that is finite element analysis, there is a computational fluid dynamics and electronic thermal management. On the left hand side, various aspects of structural analysis, that comes under FE analysis, I have just listed here, right from simple static linear to non-linear stress analysis we can perform. And then any of the explicit simulation like drop or impact or cross simulation probably automotive when it goes and bangs the front impact, that cross simulation, or else the side impact, that cross simulation can be done. Drop, why it is important, let us say any electronic component like your mobile or laptop, when it is dropped, how does it behave, still will it work? Those simulation can be done upfront, and given that design decision can be given to the designers. There's a dynamic analysis for the vibrations, fatigue for calculating the life, both in the high cycle as well as the low cycle fatigue we can do. What is the damage tolerance? Let us say there is already a crack in a particular component under a given service load. So we can see from this crack how long this product can continue before it breaks, how long it can be continued in this service, both in the crack initiation, that is called as Ni, plus crack propagation life we can find out. Ni plus Np will give you the overall life of that particular product. And then the field failure analysis. After your product is launched, it is performing its duty in the field, but you will see some failure. Then you'll have to have a quick fix. in any domain, right from consumer products to automotive or industrial manufacturing or semi, right? Or the failure analysis, that recommendation also we can give. Along with that, there are a lot of 1D simulation. Kinematic simulation means any relative motion between two parts can be simulated. How does it behave? That decision can be given. The optic simulation, predominantly on the high tech and telecom, it become more and more important. The multi-physics simulation rather than structure analysis. Along with the structure, I also want to involve thermal or else the fluid flow that can be simulated here. When it comes to the CFD simulation, right from the compressible and non-compressible fluid flow or conjugate heat transfer, wherein all three modes of heat transfer will be involved, where is conduction, convection, and radiation, right? The multi-phase simulation can be done. One important aspect within HCL is electronic thermal management, which is very, very niche. We have a very good team here to evaluate especially the electronic components. How does it behave? What can be the optimal temperature it can operate? All that can be done. So while doing all that, what is the expertise or infrastructure we have? You can see at the center one below these images, right? The 500 plus analysts are working in multiple domains. Multiple domains, I mean aerospace, automotive, industrial, medical, high tech, semi, and consumer product groups, right? So the tools, right from HyperWorks for the pre-processing till the MATLAB or else Recordine for the multi-body dynamics. You take all the ANSYS tool suites or MSc tool suites, we have it because we work with various clientele. Each of these clients will have their own requirements in terms of software. That's why you see bouquet of softwares. So whichever is applicable to the domain which people enter in, that tool training will provide to them. We have our own in-house licenses. And then what is the hardware we have? We have each workstation with 12 core to 40 core, right? So up to 512 GB RAM, that is the configuration. We also have a HPC server with 360 core. To give you an example, what is the importance of 360 core, right? 120 with 120 core, any of the aircraft complete with 50 million cell count, you can do the simulation for aerodynamic for a different angle of attack. That means that is the most complex. So simultaneously we can do 3 or 4 runs, kind of those kind of runs. That is the kind of infrastructure we have. Also, we have developed a lot of productivity tools over the years because we have a strong team of 500 plus engineers. Some of them are PhD holders, and most of them are master degree holders. These guys becomes mentors to all the freshers who come in. Before we deploy them onto the projects, we train them. We ensure that they gain the sufficient knowledge in the tool and process. Then we deploy. So we also collaborate with various institutes of high esteem within India, abroad as well, which are listed at the right bottommost corner. Okay. Why do customers approach HCL Computer Aided Engineering Solution, that is CAE Solution? So since we work with many of the customers for more than 2 decades, we understand their needs and the current business scenario, right? Most of our customers, they come to us in terms of saving the time during their product development. So that is where we develop a lot of productivity tools which will shorten overall CAE process as such. So I'll touch upon some of the how much timeline we could able to shrink using the CAE, right? With the right computer aided engineering solution, we help our customer to enhance their product performance and quality and enjoy a strategic benefits. That is a mutual benefit to them as well as us by using effective CAE techniques. Okay, why customers approach, right? In continuation, whatever I said, HCL CAE Solutions offers organizations right from complex engineering problems to address their complex engineering problems at different stages of product life cycle, whether it is at a conceptual stage or else during the detailed design phase. Many cases post they are released to the market, that is the aftermarket issues when they comes up, we quickly get into the actual scenario. We simulate that and see what could be the problem. Is it because of the wrong operating conditions, or else the material not used properly? So we will get into the root cause analysis for field failure issues and provide quick resolutions. Okay. Now, what are the major customer business challenges any CAE engineer can expect? The products are becoming complex. Earlier, like it used to be either mechanical or electronic components. Now, many of almost all products day to day we come across, right? It is a very complex when it has a mechanical structures, electronics. So, as we are trying to go for further advancement, the systems are becoming complex, and this product development is very dynamic because the user experience keeps changing every 3 years once. You have to be very dynamic, and overall product life cycle time itself is very time consuming. These are the major business challenges which we'll have to address as a CAE engineers in our day-to-day work. Okay, so some of the biggest challenges what I see is the designing better product. Every time, for an example, a consumer product group, you can see that every 6 months once the product gets changed. Whereas in medical devices, every 3-4 years your product gets changed. Whatever the scanners or the machines which are used in medical domain, 3 to 4 years once the landscape gets changed. Whereas in aerospace, every 8 years once there is a product gets changed. So why the product gets changed? They want a better design, better products with better efficiency. That is where the products have become extremely complex. It is therefore difficult to predict the impact of the design decision on the overall design, right? Any small decision you take to improve the product, you'll have to assess the complete design. That is where it is becoming very complex. It is also very iterative, right? So you'll have to design, test it, and then see whether it is meeting the required condition. Now, with the CAE, this can be virtually validated. That is where we play an important role. The other important aspect for them is time to market. If you take in a consumer product, let us say washing machine, if you take 1.5 year, by then your competition comes up with a better washing machine, or else vacuum cleaner. The product life cycle time is 3 to 6 months. If you take 9 months, though your product may be better, by then your competition is already there. He will capture the market. That is where time to market becomes very important. High prototype spend, right? If you don't use CAE technique, every time you'll have to build the physical prototype. So each prototype will come up with its own cost, and testing will add on to it. That is where the virtual validation will help our customers to reduce the cost. Now, that what are the CAE solutions we deploy throughout the product life cycle, right? Right from the concept generation. All of you have studied the strength of materials, vibrations, continuum mechanics, or finite element methods. What we do during the concept generation, using that, the free body diagrams we do, hand calculation, we give a quick solution, says that your concept will work. So directions only. So and then feasibility studies we give to them. Based on that, they go to the design, right? During the design stage, we do the 3D finite element modeling, we do structural analysis, thermal, CFD, or multiphysics simulation, and then we give our observation. We say that this product, durability is good, vibrations wise, it will meet all the working conditions, or else life, it will last for so long. That is what we give during the design development stage. Whereas during the sustenance activities, right, already product is there, then you'll have to see if there are any issues. That is the root cause analysis, or else value engineering. Existing product, how can I increase the efficiency or reduce the cost? That is how it is. Or else during the failures, corrective action and preventive action investigation. Similarly, we also do manufacturing. During the manufacturing process, the process parameter study, or else mold flow analysis, metal forming. Nowadays, 3D printing simulation, we can do it using CAE techniques, right? So HCL CAE driven solutions, I would say, so is helping our customers make the right decisions for building robust and optimized product. Our CAE solutions help simulate performance to improve product designs and assist resolving engineering problems, right? Over the years, 2 decades, we have been doing this. We started with a very small team. Now we have 500 plus spread across globally, which is a very niche skill. What are the industry domains we are catering? All these HCAE solutions we are addressing during product design and development activities for aerospace, automotive, industrial, medical, high-tech, consumer electronics, semiconductor, and consumer appliances. You can think how broad we are operating. The lessons learned from each of these domains in terms of solving the problems, physics-based problems, we take it to the other domains. That is how it is called as center of excellence. Now, quickly, I would say the role of CAE in terms of accelerating the product design. That is what we were talking about. The product, typical product design life cycle, light blue color, what you are seeing, the building blocks, right? Traditional approach. Once the idea is generated, then we go for a concept generation. After concept generation, we do the design development. You can see the testing and prototyping and manufacturing. Out of all these 5 building blocks, design development time and then the testing and prototype is the most time consuming. It takes more time. So with CAE techniques, deploying the CAE technique, this can be how design and development time can be reduced to half of it, right? Whereas testing and prototyping, not all design iterations you need to build a prototype and do the testing. You can eliminate many of the prototypes. That's why you save the time and also the cost what you incur on building the prototype for each of the design iteration, and also the testing. That is where you can reduce. Here you can see reduction in time in the design and development, and also testing and prototyping you can reduce, reduction of testing efforts and cost as well. So instead of your time to market, it used to take this longer in the traditional approach, that can be reduced at least by 25 to 30%, right? That is how it is. So effective time savings also, yes. And the C, by deploying the right CAE techniques with the right minds, and then the with good understanding of the design algorithms, we can help our customers to reduce overall product design life cycle by somewhere from 25% to 30%. That is the benefit we provide to the customers, right? So HCL driven solutions, right? What do we provide? Reduce time to market, robust and optimized design, improve accuracy, and predicting the failures of any component upfront rather than predicting after it is in the market. We also help many of our customers in resolving their field failures so that quickly they can fix the issues, so that machinery is grounded or else without idle time can be reduced. The continuous design improvement, we can keep on giving the our intuition, means our analogy, our outcome of our analysis, we can give that as a input to the design. That's how they can improve their design continuously. So what happens at the end of the day, when the product is in time, well ahead of the scheduled time, which performs to the given design intent, then it improves the customer satisfaction, right? And as I said earlier, it reduces a lot of physical testing and prototype. Okay, so the most important thing, what do we offer in the new product development? We'll evaluate strength of the product, cost and weight. We can help them to optimize the life enhancement. Let us say any product which is expected to endure in the given service load for 5 years, if you can increase it to 1 year, that 1 year is the additional benefit at the same cost for the customer. That is the life enhancement. We also do a lot of flow, thermal performance, and efficiencies. the mechanics of machines and co-simulations. And then in the emerging technologies, what all we have deployed, we have gained insights, and then we are deploying in our CAE techniques is digital twins. The test data is available. We club that, link it with our simulation data so that it performs optimal performance is ensured using the digital twin. We also do the deploy artificial intelligence machine learning algorithms into our simulation to predict what will happen if this particular strength is so much, what has happened in the past. That data we compare and we give that in insights to the customer. So electric and autonomous vehicles, that is the most advanced one which we are working. Many of the 3D printing, both on the metal as well as the polymers, we do simulate and give the insights to the designers. Earlier, all the assembly level 3D system modeling, 3D modeling was a time consuming. Now what we have done is we have developed a 1D system modeling. Whole of the assembly can be idealized using 1D system, and we give them the direction that. So your design intent is that whether are you going to meet that or not upfront during the conceptual stage, we'll do. Lot of this high-end analysis simulation, this computing, we also deploy cloud computing. Okay, the last one, the CAE automation, right? Most of the industry, it is going through the automation. How can we do the automation? So we have developed in-house automation tools to give the productivity benefit to our customer. We use Python, HCLTK, Visual Studio based apps, and also specific to the tools, APDL programming, we do it for ANSYS, and ACT programming as well. So when you come into the organization, if you decide to come into the organization, you get to see all these things. If you are interested, you will be able to interact with some of our SMEs, can learn these skills, right? Why HCL, right? We have the engineering maturity we have shown for last 2 decades. I'm talking with respect to the CAE. The automation what we have developed, which is in our DNA, because we wanted to give that year on year improvement, productivity benefit to our customers. The ecosystem, right from the CAE tools, the consultants, SMEs, what we have, that is one more important thing. We have requisite skills and experience, overall 15 plus years of experience with PhD scholars, and many of them are master degree holders, right? The service offering, broad spectrum of service offering, you would have seen 9 industry verticals we have work across. Whatever the learnings we take from one industry, we apply on the other industry. So that's how our day-to-day life is very interesting, because we get challenging problems to solve. Okay, so when you get in, what will you see, right? The process, tools, methodology, and standardization. So we work on efficiency improvement on our overall process. How can we reduce the overall cycle time within the CAE? We are very agile. We use many of the existing practices. We automate that. That's where we say agility. Cost optimization. We use the tools across, right, to quite effectively 24/7, and also our computing facility. That's why we don't put that cost onto our customer. That also helps in cost optimization. We are very flexible, and also we can scale based on the demand of the customer very quickly. That is how it is. In terms of standardization, we have standardized our process, we have a tools repository, and also we track that. And methodology, not capturing the customer specific details, only the general methodology we have captured at a central repository, which will be used by many of our engineers, right? Now, as a freshers, you come in, what is important to you is how will we train, right? An engineer with tool and simulation competency, he comes in with an individual skill. What we do is, and some of them, they don't even come with that, we do the skill gap assessment. Based on that, we have 3 kinds of training we give. HCL job based certification, which is technical, which has technical, process, domain, and soft skills. We focus on this. And then tool training. Some of that tool training our own SMEs provide, and sometimes we rely upon external trainers to give that, which if it is a very advanced one or a testing one, right? That is how. So there is a overall ecosystem, right from when we brought any when you bring any freshers, how do we take care of them? We assess what skills they bring in and what is the gap which is required to cater to current industry requirement. We upskill them or else skill them or through the training and then before deploying onto the project, right? So these are some of the customer success stories, right, from aerospace to automotive, medical and industrial customers. In the interest of time, I'm taking a pause here. Mine, that is all I wanted to talk. Thank you for the wonderful opportunity. Now I look forward for if there are any questions.
Yeah, thank you, Mr. Kenya. Yeah, so that was very insightful presentation. So now let's move on to the Q&A session. As a reminder, you can still submit questions through the comment box below. It looks like we have a few questions. Our first questions come from Hua. Can you see it?
Okay. So
Yeah.
thanks,
Main,
Hua.
yeah.
I'll take this question. Good question, right? So we showed you some of the tools which we use it during our CAE simulation, right from ANSYS. I'm just trying to go back to the presentation so that it will be easy. Okay, you can see here, right? If it is a pre-processing tool, mostly we use HyperWorks, HyperMesh, right? Only for meshing or ANSA. But ANSYS is also quite capable doing the pre-processing. Based on the customer need, ANSYS or Nastran are the tools which are used for structural simulation. Suppose if it is a multi-body dynamics, MSc Adams is the tool what we use it. If it is a explicit simulation like time-dependent simulation like crash or else impact studies, we use Abacus or LS-DYNA. When it goes to CFD simulation, Fluent, ANSYS Fluent is the tool what we use it. When we go for electronic thermal management, IcePack or Flowtherm or Star CCM is the tool what we use. But sometimes what happens, it is based on the domain. Each domain prefers to use their own tools and customer also prefers to use their own tool. As I said, we have this bouquet of services what you are seeing at the center, right from HyperWorks to ANSA, CFX, right, ANSYS, Abacus. All these tools we are quite familiar. Based on industry need and customer need, we train our freshers before we deploy them onto the project. Hua, did I answer your question?
Yeah. The next questions is going to: what are the career prospects of the person if she or he pursues a career in CAE?
Good, excellent question, right? As a fresher, you need to have this clarity. So down the line, 5 years or 10 years, how does your career looks like? Especially in CAE, it requires the continuous learning. Whatever you learned during your engineering 4 years or plus 2 years in masters, maybe strength of materials or your vibrations or continuum mechanics, finite element methods, all these things becomes very relevant here. Now every these industries are CAE example, computer aided engineering, over the years it is continuously improving. Now, earlier we used to solve only one physics at a time. Now we are in a stage where co-simulation is in place. Now we are about to start simulating about the electric vehicles at a system level, battery simulation. Going forward, what will happen at an assembly level simulation will start. Earlier, we used to have HPCs with 10 cores maximum. Now we have 360 cores or 500 cores of HPC, which can solve the complex problem that is at an assembly level. You might have seen the reason why I presented the global CAE market trend is this industry is growing at 9.2% year on year. That means that in next 6 years, the engineers required to cater to the demand is almost double. That means that there are very few industries where which is growing at almost double digit year on year. That means that you'll have an exciting career as the technology landscape is changing in automotive from conventional IC engines to the electric engines, or else the hybrid powering, or else connected devices. In all these areas, the CAE deployment of CAE techniques becomes very, very important because time is the essence as well. So CAE helps them. Definitely, a person who takes plunges into CAE or else takes CAE as a career, you'll have an exciting journey going forward. The global industry trends itself is on one indication. I'm sure all of you will have whoever picks up this will be having a continuous learning journey, which is a niche skills, and also you are a part of a service line which is continuously growing. Right? I hope I have answered your question.
Yes, next question is going to how many employees does HCLTech have in CAE globally and in Vietnam?
Okay. Right now, I said 500 plus engineers, CAE engineers globally. Now we'll be starting with the our first engagement in Vietnam. We have already started. It will start with 10 engineers, but we are expecting to grow that significantly. As you see, the semiconductor and medical devices growth is predominantly we are focusing on Vietnam, right? So as I take medical devices, which is one of the largest business within the HCL engineering R&D services, and there we work on the surgical devices within the medical domain and also many of the implants. That means that which is a very niche skill, the understanding of the materials and then the complexity in terms of non-Newtonian fluids, so which should excite any of the CAE engineers or mechanical engineers as such. We are expected to grow in from 2023 onwards in the Vietnam, especially in the semiconductor, automotive, and in the medical devices to start with. We'll be starting right from January a CAE team in Vietnam, and we are expected to grow. And this will be one of the growth engine which we are hoping. Vietnam is a growth engine for our CAE service line. Yeah.
Thanks for your answer. And the last but not least, what does a student need to study in order to get into the field in his career?
Okay. So most of the subjects which is required, you might have already gone through. In the first year, the engineering mechanics and the strength of materials you would have studied. As you move along, the fluid mechanics and turbo machineries you would have studied in second year or third year based on your university. As you move into the third year, continuum mechanics, theory of elasticity, finite element methods. These are some of the interest means important subjects which you will have to have a background. Sometimes good understanding of the material mechanics of materials will also definitely help because all this output depends upon what kind of inputs you give, right, in the CAE techniques. So you need to have a good understanding of materials as well.
Yes, it looks like we covered all of our questions. Mr. Ganga, if there is anything else you want to cover before we wrap up?
I would say that we are at a very exciting phase of technology changes. I encourage all the young students who are just about to complete their graduation or post graduation in Vietnam universities to take CAE as a career. I'm sure that it gives you a continuous learning opportunities in the niche skills. And definitely, I would like to love to see some of you joining HCL so that we can continue this kind of conversation going forward. I wish you all the best and Merry Christmas and New Year in advance. Thanks, Mike.
Yeah, great. Yeah, great. Thank you, everyone. We appreciate you still being here. One more time, thank you, Mr. Ganga, for your wonderful presentations.
Thank you.
Yeah, hope that today event will bring you useful knowledge. If you have interested in career opportunity at ACL, please visit aclvietnam.com to find out available jobs. On behalf of ACL Tech Vietnam and our presenter, thank you for joining us today and wishing you all the best for a wonderful holiday break. Merry Christmas. See ya.